We have our menu, our submenu, but those were simple warm-up cases. Now onto the dialog system. The dialog is a window plus widgets. The window is simple. An X and a Y, maybe a width and height, or bottom and right, whichever is easier for your use case. Oh, and a link to what widgets are on it. Before I know how I'm going to link them, I first need to know how I'm going to make them. The basics of any widget system. I need a draw function and a handle input function. What widgets do I have? Well, I'm going to have a label, a number control, and a button. What does the label need? Well, a position and a string. Number control, a position and a pointer to the number I want to modify. Button, a position, a width and height, or bottom right, either way. A label to tell you what the button does, and an action pointer so the button can do something. How to store this data? You could store the bytes and then have a list of pointers to that data. Fairly straightforward, but a bit of a pain to program, as you have to have an index, you have to load the pointer, and then you have to do LDY all the time to index from that pointer to read your data. But it's workable. Hardly worth a lesson though. So I'm going to go with a slot-based allocation. Looking at my current data, a 4-byte slot would be a good size. Now I can make a structure of arrays to make life easy. Why 4 bytes? Well, there is a handy trick. The Y, since I'm on a Commodore, can only go up to 25, which only needs 5 bits, leaving the upper 3 bits free. And it just so happens that I know a really nice way to dispatch based upon the upper 3 bits. And I have less than 8 types, as I need to know what type each entry is as well. The bit instruction can be used in this case. When you do a bit, the upper 2 bits of the byte are copied into the N and V flags. Thus we have 4 combinations. We split on the upper bit with branch plus and branch minus, and then we split those with the second bit using branch overflow, clear, and overflow set. I said 8. Well, we can expand this tree again by using the end feature of bit. So we do. Now the 0 flag is the 5th bit, allowing us to add another row with branch equal and branch not equal, giving us 8 code paths based upon the upper 3 bits. If you only need 4, it doesn't disturb the A register, allowing it to be passed if needed. So, upper 3 bits of type plus 5 bits of Y, X, string pointer low, string pointer high, 4 bytes for the label. The number is the same, only the pointer is now to a number, not a string. The button, however, type plus Y, X, string pointer low, string pointer high, height, width, action pointer low, action pointer high, 8 bytes. Now making the storage slots 8 bytes wide would be a waste, but you don't have to only allocate 1 slot to each item. This will cause some complications later, but let's worry about them then. So for the button, I allocate 2 slots to handle all of its data. You might be tempted to do, but if you remember the lesson from last time, you can. Now that I have the way I'm going to store my data, the way I get the window to link the data, I have a start slot index and an end slot index, which I hold in a table. And then I just hold an index into it. The next index is the endpoint. To draw, I have a branch tree as before, and then calls to the correct draw function. To move to the next slot, I have another branch tree that returns the number of slots per type. Next video, we will tackle how to handle input and focus.